Welcome to the deep dive. We're about to really get into a fascinating stack of source material you've shared with us.
Yeah, it covers some really interesting ground. A new way to think about information structure. AI
Mhm.
even touches on existential risk.
Right, and it all seems to center around this thing called the Fractal Identity Map, or AM.
That's the one. FAM. It's presented as, well, more than just another data structure, really. It's pitched as a fundamental shift.
So our mission today is to unpack this FM. We want to pull out the key ideas from these sources you sent over, figure out what it is, how it actually works in a way that clicks.
And importantly, why the sources claim it matters so much,
Yeah.
especially for making sense of complex systems, particularly AI, bringing transparency where there's often opacity.
Yeah, making things clear. I saw connections mentioned to AI governance, even quantifying trust. Surprising stuff.
Definitely. It seems to tie together a lot of threads,
Mhm.
from making AI auditable to maybe even enabling new kinds of financial markets.
Okay, let's dive in. The sources seem to start with the why. What's the motivation here? What problem is FIM fundamentally trying to solve, especially in the AI space?
Well, the material identifies this feeling. It's almost like a learned helplessness. You might have felt it yourself when people talk about AI alignment or interpretability.
That feeling that maybe it's just impossible, that we're building these black boxes we can't really understand.
Exactly that. You build something powerful, but you can't quite trace how it reaches its conclusions or if it's truly doing what you intended.
Why do you think that feeling is so, well, common right now?
It boils down to the complexity, really. Our usual methods, they struggle to give a clear step-by-step trace of an AI's reasoning. You get the input, you get the output, but that middle part,
The journey is murky.
right, super murky, like a dense neural network or those embedding spaces that seem to shift around. The sources argue this isn't like inherent to intelligence itself. It's maybe a limitation of how we currently structure the information.
Okay, so FIME comes out of wanting to push back against that helplessness.
Precisely. The team mentioned in the sources, Unrobocall, for example, they seem driven by this core belief that actually interpretability is possible. And not just possible, but empirically provable.
So rejecting the idea that AI has to stay a mystery box.
Yes. Instead of accepting the black box, they're trying to engineer transparency into the system.
What are some of the core belief statements they use? How do they phrase this drive?
They're quite direct. Things like, we believe trust in AI is not a fantasy. It's a choice we make possible. Or, we believe alignment isn't a distant dream. It's an action we take today. The emphasis is on making it happen through verifiable clarity.
Proof of its clarity instead of fear of its black box. That quote stuck with me. It sounds very proactive.
It is. And it's not just, hopeful thinking. They link this belief directly to empirical results, to practical things like audit trails, compliance, and even cost savings seen in pilots.
So it's grounded in seeing tangible benefits.
Right. And this belief, the sources say, pulls together a certain kind of tribe, as they put it. You've got AI safety folks, fintech compliance teams worried about regulations, startup founders, investors.
Anyone who really needs AI to be understandable, not just functional.
Exactly. Anyone for whom reliable, transparent AI is critical.
All right, so the why is clear. Tackling the black box problem with a belief in provable clarity. That leads us to the what. What is this fractal identity map? FIM, really.
Okay, so FEFIM. The sources describe it as a novel information structure. It's maybe left like a standard database or a simple network graph,
And
more like a highly organized multidimensional map. But the key is, the location on this map tells you a huge amount about what something is and how it relates to everything else.
so the structure is the meaning, not just arbitrary slots.
That's the core idea. It's hierarchical, multidimensional, and crucially, self-similar fractal, meaning the way it's organized repeats at different levels, like branches on a tree.
Okay, fractal. I get that pattern repeating idea. But how does it get organized? You said it encodes identity.
Right. This is the twist. It's not based on labels you just stick on things. It systematically encodes identity data characteristics of the thing itself directly into the map structure using very specific rules.
Identity into structure. How does that work mechanically?
The position, the sort of address of an item on the map, isn't assigned arbitrarily. It's computed, calculated directly from the data using something called prefix alignment.
Prefix alignment.
Yeah, and the structure itself is built from these prefixes, which are sorted in a specific way, Shortlex ordered, they call it. And that order comes from the weights and relationships between parent and child data points.
So the address flows from the data's relationships, weights, and this Shortlex sorting. This must be related to that semantic topography idea I mentioned.
Exactly. Semantic topography, or space as symbol. It's analogous to how parts of the brain are organized. Think of the visual cortex or that little map of the body in the brain, the homunculus.
Where location means something specific, this part processes vision. That part processes touch from the hand.
Precisely. Proximity and position on that brain map carry meaning. In FAM, location within the structure inherently carries semantic meaning about the data item it represents. The map, in a way, is the meaning.
That's a really powerful concept. Location as symbol. And this isn't just a metaphor. The sources mention something more concrete.
Right. They point out it's backed by a U.S. patent application. So it's grounded in, specific algorithms and technical utility, not just a nice idea.
Okay, got the what's a structured fractal map where location means something based on the data itself. Let's get into the how. What are the actual mechanics inside FAM that give it these properties, this interpretability?
Well, one really fundamental bit is that Shortlex ordering we mentioned.
Right.
The sources give a simple example. If you have strings like A, B, A1, A2, AB,
How would Shortlex sort those?
it goes A, B, A1, A2, AB. Shortest things first. Then, if they're the same length, it's alphabetical or lexicographical.
Okay, shortest first, then alphabetical. How does that help in the map?
When you apply this to the prefixes that define location, it naturally creates a hierarchy. Shorter prefixes represent higher-level, more general concepts. Longer prefixes represent more specific details deeper down. It makes the whole structure inherently navigable, from the big picture to the nitty-gritty.
Makes sense. What other mechanisms are key?
Another one is metavectors. You can think of these as like a compact summary embedded within each item, each node on the map.
A summary of what?
It consolidates the weighted influences coming into that node from its parent node, maybe other related nodes. It doesn't just say connected to X, it shows the strength of that connection.
Ah, so it's like a little provenance tag for each item,
Yeah.
showing its lineage and how much each ancestor influenced its current state or identity.
That's a really good way to put it. The sources have an example, something like 9D3D3, 9A2B2000, 8P4B2000, 7CP4B2.
Looks technical, but what's it saying?
It's showing that the identity or score of item D3D3, represented by that prefix D3D3, is defined by its influences. It's heavily influenced by A2B2, weight 9, less by B4B2, weight 8, and C4B2, weight 7. It's an explicit, traceable record right there in the structure.
So the why for that item's identity is baked right in.
Okay.
What about change? Things shift, AI concepts evolve. How does FIM handle that? Does it just drift?
That's where drift resistance comes in. This is a key difference from, say, standard embeddings in AI, where concepts can just sort of gradually shift meaning in ways that are really hard to pin down.
Ambiguous drift. Yeah, I can see how that's a problem for auditability.
Exactly. FIM tackles this using threshold-based reclassification. Changes aren't continuous and vague.
They're specific events.
Right, discrete explainable events. If the weighted influences those numbers in the metavector shift enough to cross a predefined threshold, then the edit gets reclassified. It might even move to a new position on the map.
And you know exactly why and when it happened.
Precisely. Because the aggregate weight crossed that threshold. It gives you stability and a clear audit trail that you often lack in systems with that continuous opaque drift.
That sounds way more reliable, especially for compliance or safety-critical stuff.
It definitely aims for that. And then there's a big one, the computational side, skip logic, and what they call exponential efficiency. The sources mention this factor, like CT.
Okay, let's try and unpack CT without getting too lost in the math weeds. What's the core idea?
The essence is that the FAM structure lets the system intelligently ignore huge chunks of the map that aren't relevant to what you're looking for.
Skip over them.
Yeah. Think of T as the total number of possible branches or paths at a certain level on the map. But C is the much smaller number of branches that are actually relevant based on the query or the data itself.
Okay.
And N is how many dimensions or levels deep you go. By only needing to process the C relevant branches out of T total branches in each dimension across N levels, you effectively prune away or skip an exponentially large number of your relevant paths.
So instead of brute forcing through everything, the structure itself guides you efficiently down the right path, like finding a book in a super organized library.
That's a great analogy. The address, computed from the book's identity, tells you exactly where to go. Section, subsection, shelf. You don't wander aimlessly. The FAM aims for that kind of focused navigation.
And this leads to efficiency gains.
Massive gains, according to the sources. They talk about achieving an OE cost per node for operations like explaining a decision, where E relates to the depth or complexity of the relevant path, not the total size of the map.
So the cost to explain something doesn't blow up just because you have tons of data.
Exactly. It's independent of the total data volume. They call it focused attention, which is key to reducing the computational load, the entropy, associated with searching or explaining things in huge data sets.
Well, okay, so the structure isn't just for organization, it fundamentally changes the efficiency of processing and understanding the information within it.
That's the claim. Structure enabling efficiency and interpretability.
This structured, efficient, transparent approach, it sounds like it could be useful in a lot of places. Where do the sources show FAM actually making an impact, or where do they see potential?
Well, big focus is AI governance and compliance, especially in regulated industries like fintech.
Makes sense, given the need for audit trails there.
Right. The sources talk about FIM enabling things like 98% transparent audit trails and that OE auditability we just discussed.
How does that help a bank, for example, in the real world?
It tackles huge headaches. Think about the potential fines under things like the EU AI Act, millions of euros if your AI isn't compliant or explainable, or customer churn.
People leaving because they don't trust the AI they're interacting with.
Yeah, the sources mention figures like 40% churn potentially linked to that lack of trust. A FAM is positioned as providing the verifiable proof needed to show an AI's decisions are compliant or trustworthy.
So it's not just ticking a regulatory box, it's actually about building trust and potentially saving a lot of money.
Exactly. And they mention tools built on FAM by companies like Unrobocall or the Touch.biz and pilot projects showing real savings, like $800 case a year, just from having that clear, verifiable auditability.
Okay, so finance and compliance are clear fits, but I saw something about brain-computer interfaces. BCI, that seems like a totally different world.
It does, doesn't it? But
Yeah.
it's used to illustrate that core space as symbol idea really well.
How?
The idea is FEM could map complex signals from the brain or other sensors directly into its structure. Different types of signals from different locations with different characteristics, they'd get mapped to specific prefix paths on the FEM.
So the raw signal gets translated into a sort of meaningful address on this map.
Yes, exactly. Creating what they term a semantic address bus. The meaning of the signal and how it should be routed or interpreted is encoded right there in the prefix bits of its address.
So downstream systems don't need to decode complex raw signals. They just look at the prefix.
That's the idea. The logic processes based on these semantic prefixes. This could apparently lead to a whole new kind of symbolic, sensory spatial language.
And how does that help with BCI's typical limitations, like low data transfer rates?
Well, traditional BCIs often struggle sending raw neural data or simple commands because the channel bandwidth is limited, only a few bits per second sometimes.
Right.
With FIM, mapping signals to these prefixes means the meaning represented by a prefix path can grow exponentially as the prefix gets longer, gets deeper into the map. But the actual physical signal needed to represent that prefix might still be relatively small or slow.
Ah, so you're packing more meaning into fewer bits, effectively, by leveraging the structure.
Kind of, yeah.
Yeah.
It could potentially overcome those byte rate bottlenecks, allowing for richer communication or control. And they mentioned it's potentially implementable in hardware too, like FPGAs or neuromorphic chips.
That's really clever, using the map structure to amplify the information content. Okay, and finally, how does MM relate to the general field of explainable AI or XAI?
FEM is positioned as enabling XAI by design, not as an afterthought.
What's the difference?
Well, many XAI methods like LIME or SHEP work by trying to figure out an explanation after the main AI model has already made its decision. They're post hoc. Other methods try to build alignment during training. FEM's approach is different because the explanation is inherent in the structure itself.
The explanation is just reading the map.
Pretty much, it offers in-structure provenance. When an AI using FEM makes a decision, it corresponds to navigating a path through the FEM structure. That path, defined by its sequence of prefixes like, say, symptom A2, test B, profile C3, leading to a diagnosis, is the explanation. It's explicit, it's auditable.
But the map literally shows the steps, the why.
Exactly. It provides this transparent scaffolding, making the reasoning visible right from the start.
Okay, let's shift gears a bit. The sources use a really complex and maybe controversial example to show how FEM can structure uncertainty. The whole debate around AI existential risk or AI doom.
Yeah, that's definitely a complex one. High stakes, Lots of different arguments, tons of uncertainty. It's a good stress test for structuring information.
They reference Leon Shapira's doom train analogy.
Right, the idea that there's this train heading towards Doomtown, and arguments against doom are like stops where you could potentially get off the train.
So how does FIM map something like that chaotic debate?
It takes all those sprawling arguments and imposes structure using its hierarchy and that Shortlex ordering. Different categories of factors like how fast AI is scaling, or competitive pressures between labs, governance issues, philosophical disagreements, resource limits, unexpected things.
It gives each category a place on the map, a prefix.
Exactly. Each gets a sort of identifier or prefix path, so you can systematically categorize the reasons someone might lean towards or away from the doom scenario.
It helps organize the arguments, but does it help analyze the risk itself?
Well, within that structure, you can start modeling the relationships. Like, how does intense competition maybe make effective global governance less likely? FIM's structure lets you represent those kinds of dependencies.
And then you can add probabilities.
That's the next step shown in the sources, assigning probabilities within this framework. Things like, what's the estimated chance a specific counter-argument, stop on the train, actually holds up, or the p-blocker, the probability that a factor like, say, governance successfully prevents the negative outcome.
The sources actually give percentages for these
Yeah.
p-blockers, right? And come up with an overall p-doom estimate.
They do, yeah. Based on the specific analysis in that source material, they estimate p-doom around 25%, considering the dismissal probabilities and how these factors influence each other, like competition weakening governance.
Now, it's important to stress we're not endorsing that 25% number or any specific view on AI risk here, right?
Absolutely not. The point isn't the specific number. The key takeaway from the source is how FIM provides a framework to make the structure of this incredibly complex and uncertain debate explicit.
It forces you to lay out the factors, how they connect, what probabilities you're assuming.
Exactly. It moves it from just, a collection of disparate arguments into a structured model that can be examined, debated, and refined much more rigorously. It makes the assumptions visible.
A tool for structured analysis in the face of deep uncertainty. And they connect this back to more everyday business problems.
Yeah, they draw that parallel. They argue this isn't just for abstract philosophical debates. The same FIM framework could be used to map out complex business risks. Think about the probability of a major project failing or the chances of falling foul of complex regulations.
Those also involve lots of interconnected factors and uncertainty.
Right. FIM could help map those dependencies, quantify the risks, and make the whole calculation more transparent and manageable.
So from mapping AI doom arguments to structuring project risk, it's about FIM's ability to organize uncertainty through its inherent structure.
That seems to be the core value proposition for handling complexity.
Okay, this leads us to maybe the most ambitious claim in the sources, potential economic impact. How does this structural approach supposedly open up new markets?
The sources use a really potent analogy here.
Yeah.
The Black-Scholes model for financial options.
The model that revolutionized derivatives pricing.
Exactly. Before Black-Scholes, pricing options was more art than science, kind of opaque, hard to agree on. Black-Scholes provided a computable language for financial risk, specifically volatility, and that common language basically enabled the huge, complex derivatives markets we have now.
It made an intangible risk measurable, tradable, insurable.
Precisely. And the sources argue that FIM could do something analogous for what they call AI competence risk. AI competence risk, meaning the risk that an AI system isn't reliable or compliant? Yes. FIM aims to provide a computable language to verify and quantify just how reliable, how trustworthy, how competent an AI system actually is.
And this leads to insurable competence. What does that mean?
It's the ability to actually quantify, verify, and therefore underwrite and ensure an AI's reliability. Given how much we're starting to rely on AI and the potential costs of failure, like those fines or customer churn, being able to ensure AI competence becomes really valuable.
Okay, but how does FIM make AI insurable? What's the mechanism?
When an AI system uses FIM, its decision-making processes map onto these stable, verifiable paths, these prefixes, within the FIM structure. A specific compliant sequence of steps corresponds to a unique auditable address on the map.
So that address becomes proof.
Essentially, yes. That transparent, verifiable address acts almost like a certificate of insurability for that specific behavior or decision path. An underwriter could look at the FIM structure, the provenance baked into the metavectors, the drift resistance thresholds.
And actually calculate a fair price for the risk associated with that AI's competence.
That's the idea. With a level of clarity that's just not possible with opaque systems, it transforms trust from a feeling into something quantifiable and auditable.
So it's not just showing the decision, it's providing auditable proof the process was sound.
Precisely. And the sources suggest this isn't just a minor safety improvement. They frame it as potentially transformative for the economy.
Transformative how? What are the big implications?
They talk about it potentially unblocking investment in AI. If AI competence becomes verifiable and insurable, you could create new financial instruments based on it.
Like what?
Things like AI competence bonds, maybe, or compliance-linked notes, where the return is tied to the demonstrated FIM-verified performance and compliance of an AI system.
You could securitize verified AI performance, turn opaque AI assets into something more liquid and tradable.
That seems to be the vision. And it could also revolutionize insurance itself. Think about parametric insurance.
Where payouts are triggered automatically by data.
Right. Policies could automatically pay out if FIM's auditable structure detects specific types of non-compliance or failure modes. This could even lead to things like AI insurance-linked securities or ILS, bringing capital markets into underwriting AI risk directly.
Wow. So it's positioned as potentially creating the conditions for entirely new markets, all built on this foundation of verifiable and therefore insurable AI competence. That's a huge claim stemming from just a different way to structure information.
It is a significant vision, yeah.
Yeah.
All flowing from that core idea of structured, transparent identity mapping.
Okay, so we've covered a lot of ground in this deep dive based on these sources. We started with that why, pushing back against the learned helplessness around AI's black boxes with this belief in provable interpretability.
Yeah, then we looked at what SIM actually is, that hierarchical fractal map where location is computed from data, making space itself symbolic. Shortlex ordering, prefix alignment.
We got into the how those mechanics like metavectors giving you provenance, threshold-based reclassifications, stopping vague drift, and that really interesting skip logic for efficiency, making costs independent of data size.
And we saw the applications, bringing auditability to AI governance and finance, potentially boosting BCI through semantic addressing, offering XAI by design.
And even using it as a tool to structure hugely complex and uncertain debates, like the AI risk discussion, drawing parallels to mapping business risks, too.
Which all built towards that bigger picture. FM as a potential language for quantifying AI competence, enabling insurable competence, and maybe seeding entirely new financial markets around verified AI.
The thread running through all of this seems to be FIM's power to bring structure and transparency, and through that, potentially trust to complex, often opaque areas.
It really makes the case that sometimes the bottleneck isn't more data, it's how you organize and relate the data you have. The architecture matters.
Yeah, the structure itself becomes the key.
A powerful argument for focusing on information architecture, definitely.
So, maybe here's a final thought for you, listening in. If changing the fundamental structure of information, letting location and relationships become symbols of meaning, could potentially do all this. Make opaque AI clear, maybe change human-computer interaction, even create new markets. What complex problem in your own world, your own work, might look different if you radically rethought the structure of how you represent it? Could a different kind of map reveal pathways you just can't see right now?
It's a challenge, right? To look beyond the individual pieces of data and really consider the architecture, the relationships, the map that connects them all.
Definitely something to mull over. Thanks for joining us on this deep dive. Keep exploring those structures.